everyone! Welcome back to the Climate Education Network. Today, we'll be talking about greenhouse gases. It's common for people to be confused about what does and doesn't count as a greenhouse gas, and what role greenhouse gases play in climate change. That's what we'll be discussing today. So, what are greenhouse gases, and which are the most prevalent ones? Well, greenhouse gases are the gases that contribute to the greenhouse effect. Duh. But the greenhouse effect is what allows Earth to be habitable. As you recall from our previous video on electromagnetic radiation, infrared radiation is a prevalent form of radiation emitted by the sun, as well as the approximate black body that is Earth. It turns out that most types of greenhouse gases primarily interact with infrared radiation as well. We go into more detail about this in the greenhouse effect video, so be sure to check that out. Greenhouse gases are found naturally in the atmosphere, in very trace amounts, but enough to keep the Earth warm. In fact, Earth's atmosphere is composed of 78% nitrogen, 21% oxygen, and only around 0.04% carbon dioxide, which is 400 parts per million. Other greenhouse gases are even more trace in our atmosphere. Despite being so minuscule, these small concentrations are enough to facilitate the greenhouse effect. The single most abundant and impactful greenhouse gas is actually water vapor, though the concentration of water vapor is not directly influenced by humans. Following that is carbon dioxide, then methane, then nitrous oxide, all of which are also naturally occurring, but also emitted by humans. Some non-natural greenhouse gases have also been introduced to the atmosphere due to human activity, namely a group of gases called fluorinated gases. But this chart does not tell the whole story, and concentration isn't the only factor that should be considered when comparing greenhouse gases. How long a gas stays in the atmosphere and how strongly it impacts the atmosphere are both important factors as well. Global warming potential is a variable that combines lifetime in the atmosphere with strength of absorbing energy, so it provides another dimension to comparing greenhouse gases. Over a time horizon of 100 years, methane has a global warming potential around 25 times that of carbon dioxide, and nitrous oxide has a global warming potential around 300 times that of carbon dioxide. Let's take a closer look at how carbon and methane can exit the atmosphere. The carbon cycle has two main carbon sinks, meaning carbon dioxide can exit the atmosphere in two main ways: photosynthesis or ocean absorption. Plant photosynthesis has the effect of converting carbon dioxide into biomass, and over tens of thousands of years will be moved deeper into the earth and become fossilized. Remember, using fossil fuels is really just extracting decomposed biomass from the earth and introducing that carbon back into the short-term carbon cycle. Extracted carbon that really should have stayed in the ground is what's upsetting the balance of the natural carbon cycle. Oceans also absorb a significant amount of carbon dioxide, but we can't rely on this to counteract rising carbon emissions because increased carbon dioxide levels in oceans cause ocean acidification. We'll talk about ocean acidification in a later video. Methane, on the other hand, does not linger in the atmosphere for as long as carbon dioxide, with an average lifetime of only 12 years. Furthermore, methane in the atmosphere reacts with hydroxyl radicals and produces water vapor and carbon dioxide, reducing the concentration of methane, but producing more carbon dioxide. This means that if we took immediate action to reduce methane emissions, our atmospheric concentration of methane would quickly return to normal in just a few decades, and even also help reduce carbon dioxide concentrations in the long run. While these global warming potentials may sound scary, remember that they are determined by the physical and chemical properties of the gases, something we have no control over. This means it's not the presence of them that is contributing to climate change, but rather the concentrations of them. This is why climate change is such a time-sensitive problem. Even if we stopped all carbon emissions today, the effects of the carbon dioxide we already emitted into the atmosphere will persist for decades to centuries. This is why only reducing carbon dioxide emissions is not enough. Reducing methane emissions as well would allow us to have a much quicker effect on slowing down global warming. And with that, we hope you now have a better understanding of greenhouse gases. There are still many more topics to be covered, so stay tuned for more content. Thank you for tuning into the Climate Education Network, and goodbye for now.